Good evening. I am Somak Nath, a research scholar at School of Mathematics and Statistics, University of Hyderabad. So today I will solve a problem from assignment 11 of week 11 of partial differential equations of previous year. So let me first show you the questions. Questions are from question number 8 because from question 1 to 7 has been done by Soikat. So question number 8 is that. So common data for question 10 to question 8 to question 10. So question number 8 is for let lambda is a real number. Consider the following Newman boundary value problem for the Laplace equation on the annular region B25, that is a circle with center at origin and radius 2. Another circle is center at its origin and radius 5. Now we have to take the annular region, annulus between these two regions, where u satisfies this Laplace equation with boundary condition is given as follows. So question number 8 is that what is the value of lambda for which the given boundary value problem has a solution. So lambda is here, lambda is del in u 5 comma theta, here lambda is present. So first you have to find the solution of the form polar form. So what is let me first write the question, then I will solve. So the question is, question number 8. Question is Laplacian u is equal to 0 in B25, that is equal to those r comma theta such that r comma theta in belongs to 0 infinity cross 0 to pi, such that 2 less than r less than 5, and what in the boundary conditions are Newman boundary value problem. So derivative of boundary condition for the derivative of u, n is the outer done unit normal. At the boundary it is minus 5 by 2 sine theta minus 5 by 2, where theta lies between 0 to 2 pi, and del nu at another boundary 5 comma theta is 3 lambda cos square theta minus 4 sine square theta, where theta again lies between 0 to 2 pi. So you have to find the value of lambda for which this equation 8 has a solution. So solution, since it is given that the initial in the boundary the u is given in terms of sine theta and cos square theta sin square theta. Since sin square theta and cos square theta can be written in terms of cos 2 theta. So uh, the boundary condition is given in terms of, you can say the boundary condition is given in terms of sin theta and cos 2 theta. So we expect the solution in have the form like this I am writing. So so see, the boundary condition is given in terms of, let me write the boundary condition is given in terms of sin theta comma cos square theta and sin square theta, and cos square theta and sin square theta can be written as in the trigonometric function cos 2 theta. So that is in terms of sin theta and cos 2 theta. So we expect the solution of a particular form, that is, so we expect the solution of particular form like u r comma theta equal to d0 ln r plus sin theta into c1 plus, that's why I took sin theta and cos 2 theta. I will take d1 by r plus cos 2 theta into c2 plus d2 by, sorry, c2 r square plus d2 r. Just I have to write r and r square there. This is c1 r, here it is c2 r square and d2 by r square. I took because I know that you from, let me show you the question from question number 5. You know that the solution is in, if you use separation of variable, solution is in option E. Okay, now I am choosing particularly I'm choosing particularly sin theta and cos 2 theta because my initial condition is given in terms of sin theta and cos square theta sin square theta, and cos square theta and sin square theta can be written as cos 2 theta. That's why I choose the solution like in particular form like this u r comma theta. Now I will find the value of c0 d0 c1 d1, then find the value of lambda from that. So let me since boundary condition is given Newman boundary, so I have to find the derivative. So let me find first del u del r, del u del r, that is out of the normal derivative, that is d0 by r plus sin theta into c1 minus d1 by r square plus cos 2 theta into 2c2r minus 2d2 by r cube. So 2d2 by r cube, 2c2r minus 2d2 by r cube, that I will write here. 2c2r minus 2d2 by r cube. Okay, this is cube. Okay, fine. So let me go to the next page. Okay, so I got the solution and its derivative. Like since the boundary condition is given Newman boundary, that is derivative, so we will find del u del r. Now I will find, I will put r equal to 5, del u del r at r equal to 5 comma theta. So from the outside boundary condition, let me write that is del u del r at 5 comma theta. We have this is given, it is given as 3 lambda cos square theta minus 4 sin square theta. It is given. Now I will use, I will change this cos square theta and sin square theta by cos 2 theta because both can be changed by cos 2 theta. So I will write 3 lambda by 2 into 2 cos square theta minus 2 into, somebody wants to join, I think. 2 into 2 sin square theta. 2 sin square theta. 2 sin square theta means 1 minus cos 2 theta. So 3 lambda by 2 into 2 cos square theta means 1 plus cos 2 theta 2 sin square theta means 1 minus cos theta. So that is 3 lambda by 2 minus 2 plus 3 lambda by 2 plus 2 into cos 2. Okay, so now we have what we have from the initial condition is that from the boundary condition is that del u del eta, eta is r, del u del r at 5 comma theta is 3, this 3 lambda cos theta minus 4 sin square, that I found. Now I put this del u del, I will put r equal to 5 in this condition, in del u del r here, in where I put a right symbol here. I will put del u del r. Now r equal to 5 I am putting. Del u del r at 5 comma theta is d naught by 5 plus sin theta into c1 minus d1 by 25 plus cos 2 theta into tan c2 minus 2d2 by 125. Why? Because I am putting r equal to 5, d 0 by 5 plus sin theta into c1 minus d1 by 25 and raised to 10 c2 into minus 2d2 by 125. So I will compare these two relations. Then I will find d0 c1 d1 c2 d2. So comparing we get what we get. Comparing we get, let me show you, compare these two, this last two line. So d0 by 5 equal to 3 lambda by 2 minus 2 d0, and coefficient of cos 2 theta is 1 and coefficient of cos 2 theta is 3 lambda by 2 plus 2 and coefficient of sin theta is 0. Sin theta is 0. So c1 minus d1 by 25, that is 0, and 10 c2 minus 2 d2 by 125, that is 3 lambda by 2 plus 2. So let me call this system as system 1. Okay. Now again from inside boundary condition, let me write, I have inside means at r equal to 2. It is minus 5 by 2 sin theta minus 5 by 2. Since both are minus, so I have to put plus, because del the because this del in u is the normal derivative pointing away from the origin. Now however we want the however we want, what we want that the del u del r pointing inwards, since it is inside, so pointing inwards, therefore we have to put negative sign here, minus del u del r equal to this, because I am writing the why I took like this, because del eta u is normal derivative pointing away from origin, pointing away from origin. But here we want normal derivative pointing inwards the origin, because our condition is u r lies from 2 to 5. Okay, so 2 is the inside circle, so we want inward direction normal vector. But here here the initial condition is given, del nu. Del nu means outward normal, so we have to put minus del nu 2 comma theta, minus del u del r 2 comma theta. It is equal to minus 5 by 2 sin theta minus 5 by 2. That's why minus is coming. So again I will put r equal to 2 in this right this let me give you one this equation as equation number star. So I will put r equal to 2 at star. This is star. Okay, so from star putting r equal to 2 at equation star, what we get is that del u del r at 2 comma theta equal to, I just put r equal to 2, nothing else, sin theta into c1 minus d1 by 4 plus cos 2 theta into 4c2 minus 2d2 by 8, 2d2 by 8. So again, if I compare, I compare these two equations, del u del r at 2 comma theta and del u del r these 2 comma theta. So comparing this last two equation I got, let me show you the equation. So let me write comparing. We get, what we get is that d0 by 2 equal to 5 by 2, because here it is minus in the left hand side. So d0 by 2 equal to 5 by 2, and this is 5. Okay, and second equation is c1 minus d1 by 4, that is coefficient of sin theta is minus plus 5 by 2 again, because here it is minus in the left hand side, and coefficient of cos 2 theta is 0. 4c2 minus 2d2 by 8 means d2 by 4 equal to 0. So this is another system, equation number 2. Okay, so from equation number first equation of equation 2 we got d0 equal to 5. So from first equation we have to find lambda. So from first equation of equation 1, if we put d0 equal to 5 we get lambda, right? So let me so d0 equal to 5 from first equation of system 2. Okay, d0 we got 5. Now from first from 1 system 1 first equation we have uh, so from system 1 first equation we have, I put d0 equal to 5. Let me show you the system 1 first equation, this equation. So I will put d0 equal to 5. So 5 by 5 equal to 3 lambda by 2 minus 2. 5 by 5 equal to 3 lambda by 2 minus 2. So 5 cancel out. This is, sorry, 1 equal to 3 lambda by 2 plus 2 minus 2. So lambda 3 lambda by 2 equal to 3. So lambda equal to 2, which is the value of the lambda. This is our desired solution. We have to find value of lambda for which the equation has a solution. Lambda equal to 2. So let me show you the question again. Question is, find the value of lambda for which the given boundary value problem has a solution. So lambda equal to 2. So option D is correct. Option D. Okay. Answer is option D. Okay. So this is my first problem number 8. So now the second question is, let lambda be such that the boundary value problem, let lambda be such that the boundary value problem has a solution. That means lambda equal to 2 I already got. So you have to find the solution. Let UA r comma theta is the family of solution of the boundary problem indexed by A. That is my C0 is A. You have to find C1 D1, C2 D2, then you have to find the solution. That's it. So let me just do it. So from previous from one system one. From system 1 we already got D0, so now we find C1 and D1. From system 1 equation 2 we got C1 equal to D1 by 25, and then I will put it in system 2 equation 2. So I will get D1. So let me, you have to solve for C1 D1 C2 D2 to get the solution. So problem number 9 is from system 1 equation 2 equation, from second equation I will put from system 1 second equation I got C1 equal to D1 by 25. Now from system 2 second equation I will put this value of C1 system 2, this C1 equal to D1 by 25 I got. So D1 by 25 minus D1 by 4 equal to 5 by 2. So that means 4 D1 minus 25 D1 by 100 equal to 5 by 2 I got. Minus 21 D1 equal to 500 by 2, that is 250. So D1 equal to minus 250 by 21, and C1 equal to D1 by 25. So I will put, so C1 is D1 by 25, that is 250 minus 250 by C1 equal to D1 by 25, that is minus 250 by 21 by 25, so minus 10 by 21. And from the second equation system 2 third equation we get C2 in terms of D2. Now I will put this C2 at system 1 third equation. So from system 2 third equation I am finding the solution, so that means I have to find the value of C1 D1 C2 D2 from system 2 third equation. We have C2 equal to D2 by 16. For C2 is, that is we have 4 C2 equal to D2 by 4. So C2 equal to D2 by 16. Now I will put this from system 1 third equation. So from again system 1 third equation, I will, let me write it in the next page. System 1 third equation, we got that what I will show you again. So system 1 third equation is 10 C2 minus 2 D2 by 125 equal to 3 by 2 into lambda. Lambda we got as 2. So I will put lambda equal to 2 and then calculate. Because for lambda equal to 2 we have solution. So I will put the value of C2, that is 10 D2 by 16 minus 2 D2 by 125 equal to 3 by 2 into lambda equal to 2 plus 2. So we got 5, this is cancel out 5 and 8. So 5 d2 by 8 minus 2 d2 by 125, that is equal to these two cancel out, 3 plus 2 is 5. So we got is 1000 and 625 d2 minus 16 d2 equal to 5. So we got 625 minus 16 is 609. 609 d2 equal to 5000. So d2 equal to 5000 by 609. It cannot be factorized, so it is the form. No, it can be factorized. No, it cannot be factorized. Sorry. So C2 equal to, now my C2 equal to D2 by 16, that is equal to 5000 by 609 into 16. So this can be factorized because 22500, again 1250, it is 4, it is 2, 625. So 625 by 18, 12, 12, 18. So let me write. So I got C1, D1, C2, D2. So and D0, I got D0 equal to 5 in my problem 8. So I got the solution indexed by A. You have to find, or let me show you again. So you have to find the solution indexed by A. Indexed by A. That means your C0 is A. And rest you I know. So my solution I will write, then I will check with the answer. Solution I write here. Solution is u a r comma theta equal to a plus 5 ln r plus minus 10 by 21 r minus 250 by 21 r. I just put the value of c1 d1 and c2 d2, nothing else, plus 625 by 1218 r square c2 plus 5000 by 609 r square d2 into cos 2 theta. This is my answer. So let me check with the options. Option is 625 by 128 and 5000 by 609, but 10 by 21 to the option answer D. Option D I got. Let me show you. Option D you can check. This is option D, and I am showing you my options, and this is option D. So answer is option D. Answer is option D. This is my answer. So this is my answer. Option D. So this solves problem number 9. Problem number 9. Now I will go for problem number 10. Problem number 10 is that I will show you the question. I will show you the question now. Problem number 10. That is, let lambda be such that the boundary pool problem has a solution. That means lambda equal to 2. The same problem. Same question number is 8 to 10. Question 8 to 10 has common data. That means problem is same. So lambda equal to 2. Lambda be such that the given boundary problem has a solution. Ua equal to ui r theta with the family of solution indexed by a. Let if a is such that integral over ua 3 comma theta, that is our radius u2 plus 3 center at origin, then what is a? So just you have to find the integration of ua 3 theta by putting r equal to 3 in my ua, this last equation. So problem number 10 is circle with radius center at origin and radius is 3. Okay, so integral of ua 3 comma theta d theta equal to 1, that is given. Okay, so I just integrate integrate of this. So integral of, okay, somebody wants to join. So hello, Srinivas. So showing you the question first. I'm solving assignment 11 of previous year. Okay. So
Good evening, sir.
good evening. I'm
Okay,
so
sir.
are you able to see the screen?
Yes, sir.
Okay, question number 8 and 9 I already solved. Okay. Question number 8 and 9 I already solved.
Okay, sir.
So you just saw the question number 8. Just uh, this is question number 8. I will show you how I solved this.
Sure, sir.
This is question number 8, and here what I did is that Laplacian of u is 0 is given, and Newman boundary problem, that is derivative of u is given at the boundary. So what you have to find the value of lambda. Here is my lambda. So del u 5 u at 5 comma theta. Derivative of u at 5 comma theta, it is given in terms of lambda. You have to find the value of lambda for which this equation has a solution. Okay. So what I did is that, the general solution is given in like this: c0 plus d naught ln r plus something sine theta plus cos 2 theta. But why I took sine theta and cos 2 theta, that I wrote because the boundary condition is given in terms of sine theta and cos square theta and sin square theta. But cos square theta and sin square theta can be written in terms of cos 2 theta, right? So I will write the solution in terms of only sine theta and cos 2 theta. So the solution is this. Now I will find, now it is giving Newman boundary value problem, that is derivative of u at 2 comma theta and 5 comma theta. So I will find del u del r, normal derivative. Then I solve these equations and I compare this thing and solve. Okay, I found the value of lambda as 2. Okay, and for problem number 9, I just solved they are saying for lambda equal to 2, what is the solution? For lambda equal to 2, what is the solution? Is the screen visible? Problem number 9.
Yes, sir.
Okay, so for lambda equal to 2, what I did, I have to find the solution. That is, I find the value of C0, D0, C1, D1, C2, and D2. Then my solution, I just got option number D. Okay, so this is, and now I am solving problem 10. Okay,
Sir, can you show the problem number 9 answer?
yeah, this is already this video is recording. So after this class, I will put it in that channel, and you can solve how I solve this. Okay.
Sure, sir.
Huh. From system this is problem number 9, that I solve this system 1 and system 2. C1, I find the value of C1, D1, C2, and D2. This is problem number 9 solution. Okay, just it is the elementary calculation. Just you have to find C1, D1, C2, D2, and then put it in this u r comma theta. Then you got the solution. I got it as option D. Okay, okay, is this fine? You can check this video is recording is going on. Okay, hello, are you there? Hello.
Yes, sir.
Uh-huh.
Visible.
Okay, so I'm solving question number 10, that is just we have to find the value of a. Okay, such that this integral equal to, but it should be equal to 0, I think. It is equal to 0. Okay, there is a typo in the question. Okay, so what is u at 3 theta? It is just 8 plus. I am writing this u a r. I am replacing r by 3 here. U a r comma theta in this right, double right. Okay, so I am just replacing. This is a plus 5 ln 3, right? Plus wherever there is r,
Sir,
I am putting 3.
hello, sir.
Hi, yes, tell me.
Sir, in this problem, what they are asking, can
They are asking to find the value of a. I am showing you the question again. Find the
find
value
the
of
value of a.
small a. They are asking if a is in R, this integral is, it is 0. It should be. Huh? If it is 1, then no one option is correct. When the domain of integration is a circle of radius 3 having center at origin, then you have to find the value of a, for which this integral value is 0. Okay.
Sure, sir.
Okay. So this is just I am putting r equal to 3 because I have circle with center at origin and radius 3. So this is 3 into, I am putting r equal to 3. So 251 by 21 into 3 sin theta plus 625 by 12183 square minus plus sorry plus 5000 by 609 into 3 square into cos 2 theta d theta, and theta range is from equal to 0. Theta range is from minus sorry 0 to 2 pi, right? Circle with center at 0 and radius 3. So theta range from 0 to 2 pi. Now you know that integral 0 to 2 pi sine theta is, this is a constant, right? 10 by minus 10 by 21 into 3 minus 250 by this thing 21 into 3, this is a constant. So integral of sine theta from 0 to 2 pi is 0. Integral of cos 2 theta from 0 to 2 pi is again 0. You know this thing. I think you know. Integral 0 to 2 pi sine theta is what? Minus of cos theta. Cos theta from 0 to 2 pi. And cos of 0 is 1 and cos 2 pi is 1 and cos 0 is also 1. So it is 0. And integral 0 to 2 pi cos 2 theta d theta means it is sine 2 theta by 2, 0 to 2 pi. Sine 4 pi is 0, sine 0 is 0. So it is 0, right? This is fine. Uh, fine, Srinivas.
Ah, yes, sir.
Okay. So I just integrate this thing. So these two term will give 0, right? The last two term. So the first two term will give the value of a. So I'm just removing this thing. Okay, so just 1 minute. Okay, so I'm just integrating. So this will give a into 2 pi plus 5 ln 3 into 2 pi, right? That is plus 0 plus 0, that is equal to 0, right? Because sine theta integral is 0, 0 to 2 pi and cos 2 pi is also 0. So I got 2a pi plus 10 pi ln 3 equal to 0. So what is a? A is minus 10 pi ln 3 by 2 pi, that is minus 5 ln 3, right? Is this okay?
Sir,
So yes, tell me.
sir, what is a is equals to minus 10 pi ln 3 by 2 pi.
Because 2 pi a equal to minus 10 pi ln 3 and I divide by 2 pi from this line, from the previous line. This is 2 pi a equal to minus 10 ln 3, right? So what is a? A is minus 10 ln 3 by 2 pi.
Okay, okay.
So that is minus 5 ln 3 ln 3. So the solution is what is a? A is minus 5 ln 3, the option E. That is option E, accepted answer. Okay,
Okay,
option
sir.
E is correct. Okay, so problem number 10 is solved. Answer is option E. Okay. So now I will move to problem number 11. Problem number 11 is that, let me show you the question. Question is, let D denote the dx x square plus y square less than 1. That is inside a circle. Circle is centered at origin and radius 1. And U be the U is C2 intersection with C of D closure. That is twice continuously differentiable on the inside the region and one time continuous on the boundary. U is a harmonic function on D. Can you mute yourself? Can you mute yourself so it will be better because it is recording.
Oh, okay, sir.
Huh. Whenever you want to ask something, you can unmute.
Oh, sure, sir.
Okay. Let U is C2 D intersection C of D closer be a harmonic function on D. Now, if U is y plus 2 for on the boundary, that is for xy such that x square plus y square is 1, then the value of maximum value of U in D. So I will write this thing and then I will see that let D be the D. What is the region D? D is that those x and y in R2 such that x square plus y square less than 1. So D is this inside circle region. This is radius 1. So D is this region inside this circle. Is D. And U is a harmonic function on D. And U is in C2 of D intersection C of D closure. U be a harmonic function. Harmonic means U satisfies Laplace equation. You know this thing? Harmonic function on D. Okay, so maybe you are writing something. Yes. So
Nothing, sir, nothing.
okay, okay. Actually, U is a harmonic function. Okay, that means you know the maximum principle. Maximum principle, you know.
Ah, yes, sir.
So what is the if U is a harmonic function in a bounded region, then where do you attain its maximum value? Where? Can you tell me? Otherwise, I will tell. No, no need to worry.
Yes, sure, sir. You can tell, sir.
Huh? Sorry.
Yes, sir.
U is a harmonic function, and where should you attain its maximum in a bounded region? Can you tell?
No, sir, I don't know correctly.
Okay, okay. I will tell. No need to worry. Actually, if U is a harmonic function, then U attains its maximum on the boundary. Okay, on the boundary. So what is giving in that question? I will show you the question. Question is U is y plus 2 on the boundary on x square plus y square equal to 1. That is the boundary. So what is the maximum value of U? So let me write in the next page that this is the U is given, right? Now U x comma y equal to y plus 2 for those xy which are in the boundary or xy such that x square plus y square equal to 1. So u equal to y plus 2. Now from the maximum of the function is y plus 2 on the circle x square plus y square equal to 1. Now by maximum modulus principle, or you say by maximum principle, maximum of the function u on the circle x square plus y square equal to 1 attained at uh, on the boundary. So maximum value of u attained on the boundary. Now on the boundary maximum value is given as y plus 2. Now on the boundary value is y y plus 2. So what is the maximum then? Let me draw the picture. This is x square plus y square equal to 1 bounded. Here y equal to 1. Other y value is, here y is 0, right? 0 comma something, y is 0 in this line. Here y is 1. So maximum value attains on this boundary. And on this boundary value, maximum value is attained is y equal to 1. So since y plus 2 function value is u is y plus 2, right? So maximum value attained at y equal to 1, right?
Okay, sir.
Maximum value attained at y equal to 1, right? So because you know that, let me begin by another way. Y plus 2 at the boundary x square plus y square equal to 1. So that means x equal to cos theta and y equal to sin theta. So uxy is what? Sin theta plus 2. Now maximum value of sin theta is 1. What? 1. And it attains at theta equal to this pi by 2. That means y equal to 1. So maximum value attains at y equal to 1, right? And what is the value? Value of value is, so maximum value is u equal to, maximum value is u at y equal to 1, that is y equal to 1 is a 1 comma 1, that is 1 plus 2, that is 3. This is the maximum value. Okay, maximum value is 1 plus 2 is 3, because sine theta plus 2, so maximum value of sine theta is 1, so 1 plus 2 is 3. Okay, so answer is 3. 11, question number 11, answer is 3. Okay, this is the accepted answer. Okay, so this is my answer. Okay, do you have any question?
No, sir.
Okay, then question number 12 is same. You just look at the question. Question is that u is boundary is x square plus y square less than 1. Same boundary, and u is a harmonic function. U is, now what is the change from 11 and 12? Can you tell me? Question
Which question, sir?
11 and 12 question. So what is the change?
What is the?
Boundaries change of the function. Change means where u, here I am telling you, here u is
Sir,
y plus, uh,
you is x of y is 2x square, sir, here. In our
here
question 12.
yes, that means only this is
Boundary
changing.
interval.
Bound same interval, same thing, same region. So what you have to do is that the same procedure. Maximum value attains on the boundary, and on the boundary u is 2x square. So maximum value attains at x equal to 1, because 2x square means 2 cos square theta, and maximum value of cos theta is also 1, right? So answer is 2 cos square theta, and maximum value of cos theta is 1, so 2. So let me write this thing. Question number 12 is that ux comma y is the same question. Uxy is 2x square on x square plus y square equal to 1, and maximum value attains on the boundary. ক্লাস নিচ্ছি এখন, and attains maximum value attains on the boundary, and on the boundary, on the boundary x equal to cos theta and y equal to sin theta, right? So what is u? Here u equal to 2 cos square theta, and what is the maximum value of cos square theta? It is 1, right? So maximum value is
1.
2 into 1. Maximum value of u is what? 2 cos square theta, so 2 into 1 square, that means 2 into
2.
1, 2. 2 is the answer, right? So let me
Yes.
show you the answer. Maximum value is 2, option is 2. Okay, same problem, same thing.
Okay, sir.
Okay, so this is the answer. Then I will move to question number 13. This is, let me write just answer. So next page, question number 13.
So still how many questions are remaining?
Uh, Remaining are only question number 13, 14 and 15. That is easy. 14, 15 are easy. 13 you have to do by some method. Just question number 13 is that.
Okay, sir. Okay.
Huh.
Because I have another session from 7 o'clock. That's
Okay. So, but I want to finish this. So, if
okay,
you
sir. No
if
problem.
if you have session, then you can. Video is recorded. Recording is going on. Okay. So you can check in YouTube where I upload this. Okay.
Okay,
So.
sir. Sir, one more thing. If you share your email ID so that if any get any doubt, I will clarify with through email ID. It's possible,
Uh,
sir.
Actually, for this means since there is one form, one in your NPTEL session. So in that, if you feel that we got email or my sir will get email, your the Shivaji sir, under whom you are doing the videos, right? Who is doing the videos? So not my email ID. There you find, okay. I mean, if you have to solve, fill the form, there is one form,
Means
okay.
in my NPTEL portal, the option is there, sir, for
Ah,
asking.
yeah, there is option for asking any doubts. So in that doubt, we all will get mail. There is another TA, so he will also get mail. Supervisor Sir will also get email, and I will also get email. Okay,
Okay, sir. Thank you, sir. Bye, sir.
okay, bye. Thank you. So question number 13 is that, so be a ball with center at origin. Just so, yeah. So be a ball at center at origin to, and you see the solution of this Dirichlet problem. You have to find using Lagrange multiplier method or otherwise determine which of the following points are the critical point for the function x power 4 plus y power 4 subject to x square plus y square equal to 9 these constraints. So the Lagrange multiplier method I will tell you, and critical point means the point where it attains maximum solution or minimum value. Maximum value there is critical point. Critical point means extreme points. So as the you have to find fxy is given as x power 4 plus y power 4 with condition is x square plus y square equal to 9. So while, sorry, 9 equal to 9. So Lagrange multiplier method is you have to introduce one lambda Lagrange multiplier. So Lagrange's multiplier method, that means you have to point to this one lambda. The g is a function g, x, y, and lambda, which is f minus lambda into this condition x power 4 plus y power 4 minus lambda into this condition x square plus y square minus 9. Okay, so what we have to find is that we have to solve this system of equation. Solve, sorry, solve, solve this system gx equal to 0, gy equal to 0, and g lambda equal to 0, and find the value of x, y, and lambda, and then find the value of x and y from that. So you get the extremals or extremum, that means maximum of f. This is called the Lagrange multiplier method. So I will find gx equal to 0, that is 4x cube minus lambda into 2x equal to 0. That means x equal 2x, that means 2x into 2x square minus lambda equal to 0. Gy equal to 0 means 4y cube minus lambda into 2y, that is equal to 0. That means 2y into 2y square minus lambda equal to 0, and g lambda equal to 0 means x square plus y square minus 9 equal to 0. G lambda means derivative of g with respect to lambda, partial derivative. Gx means partial derivative of g with respect to x. So what I got is that solution. What are the solution possible? Solution are, sorry, solution are x comma y are 0 0, x 0 y 0, or 0 and x is 0 and y is lambda by plus minus root over lambda by 2. Just solving. Another is plus minus root over lambda by 2 x, y is 0, and another is both are plus minus root over lambda by 2, plus minus root over lambda by 2. Now you check which of the following x and y are satisfied this third relation, x square plus y square minus 9 equal to 0. So xy equal to 0 0, it does not satisfy it, it is not satisfied, not satisfying this condition, x square plus y square equal to 9, that is x square plus y square minus 9 equal to 0. This condition it is not satisfying, so I exclude this point. And from second and third condition, from second and third condition, from second and third condition I got that if you put x equal to 0 or y equal to plus minus root over lambda by 2 or vice versa, that is x equal to plus minus root over lambda by 2 and y equal to 0, you get the same relation, that is lambda by 2 equal to 9 square. I'm squaring this, x square plus y square. So either x or y is plus minus root over lambda by 2. So from this I got lambda equal to 18, right? Sorry, lambda equal to 18. So what is my x and y in that case? My x and y are lambda equal to 18. So x comma y is either plus minus root over lambda by 2, that is root over 9, that is 3 comma 0, or 0 comma plus minus root over lambda by 2. This is another. And for the fourth case, that is both are plus minus root over lambda by 2, I will put it. So for from the fourth case, when both are plus minus root over lambda by 2, I got x square, that is lambda by 2, plus y square lambda by 2 equal to 9. So I got lambda equal to 9. So what are the x and y? In that case, x comma y are, these are the critical points, all these three, plus root over lambda by 2, that means 3 by root 2, root over lambda by 2, 3 by root 2, lambda is 9. So x and y I got, uh, x and y I got this one plus 3 by 2, this one 0 comma plus 2, and this one. So let me check which are the solution. So I got 0 comma 3 comma 0, I got option C are correct. I got 3 by root 2 comma the comma minus 3 by root 2, that is also correct, and others are not correct. So C and D are correct option. C and D are correct option. Answer is C and D. I am taking 3 by root 2 and minus 3 by root 2. You can take also minus 3 by root 2 comma plus 3 by root 2, but this is not in option. So options are option C and option D for question number 30. So I will show you the question again. This is option number C, 3 and 0 and 3 by root 2 comma minus. If the answer is, if the another option is minus 3 by root 2 comma 3 by root 2, then it is also a solution. So option C and D are here correct. So let me show you the question number 14, that is which one of the following is the maximum value of u on V. So you know, you can show that now the question is that u is Laplacian u is 0. So it is u is a harmonic function. So harmonic function attains its maximum value on the boundary, and on the boundary u is given x power 4 plus y power 4. So maximum value attained on the boundary. Boundary means x square plus y square equal to 9, this boundary. So let me just write. So the region is x square plus y square equal to 9. This, and maximum value of the maximum value of u of harmonic function attains on the boundary. So on the boundary, any point value, actually I got that on the boundary points are 3 comma 0 plus minus 3 comma 0 plus minus 0 comma plus minus 3, and this 3 by root 2 comma 0 3 by root 2. So what are the value? So u at plus minus 3 comma 0 or what? Plus minus 3 square, sorry, u, what is u? U is, let me show you the question. U is 3 power, u is, u attains is maximum on the boundary, and on the boundary u is x power 4 plus y power 4. So I have to write plus minus 3 power 4 and 0 power 4. So that is plus minus 3 power 4 plus 0 power 4, that is on the boundary, and uxy equal to x power 4 plus y power 4 on boundary. And we already got the critical points are plus minus 3 comma 0, 0 comma plus minus 3, and 3 by root 2 comma plus minus 3 by root 2 comma plus minus 3 by root 2. So this is 3 power 4, this is 81. And what about u at 0 comma plus minus 3? That is again 0 power, that is same, that is 3 power 4 equal to 81. So what is the maximum value? Maximum value is 81, because if yeah, another point, what is another point I got? Another point is, this a critical point means what? Then we got maximum value. Another point is 3 by root 2 plus minus 3 by root 2 comma plus minus 3 by root 2. Let me find what is u at plus minus 3 by root 2 plus minus 3 by root 2. So that is 3 by plus minus 3 by root 2 power 4 plus plus minus 3 by root 2 power 4, that is 81 by 2. So what is the maximum value? Maximum value is 81. So maximum value of u is equal to 81. This is my answer. Let me show you the question. Maximum value is 81. So option number A, first option. And question number 15 is that which of the following is the minimum value of u? Again, maximum by the minimum value principle is that minimum value also attains on the boundary. And on the boundary, we got the critical points at plus minus 3 comma 0, 0 comma plus minus 3, and plus minus 3 by root 2 comma plus minus 3 by root 2. That means between these three values, we have maximum and minimum. So I already got maximum as 81. So minimum is 81 by 2. So question number 15 is that just minimum value attained on the boundary. Minimum value of u attains on the boundary, and for what, for x comma y equal to plus minus 3 by root 2 comma 0 comma plus minus 3 by root 2, we got minimum value. So value is, we got minimum value, because otherwise we got 81, which is maximum value, and here we got 81 by 2, which is less than 81. So it is the minimum value. We got minimum value. So value is 81 by 2. This is the answer for question number 15. So let me show you. 81 by 2 is option C, and third number. So with this, all the questions are solved. So that's it. Thank you. Thank you very much.